everybody. Hope you are not starving, but I will try to be quicker and conciser. How many of you is using Prometheus stack? Like a lot of people, right? And how many of you is caring about setting limits, thinking about like predicting? Okay, 1, 2, 3, 4. Okay, just a few. That's cool. So I hope we have some learnings today, or at least review some base knowledge. So today I want to tell you a tale about a company named Unbounded Metrics. So this is a very cool name, right? And the Unbounded Metrics was a fast-growing tech company focused on real-time data analytics. It's a pretty fancy business. And as the Unbounded Metrics expanded their business operation, they start to looking for monitoring tool where they could use to building an internal monitoring platform. And this tool needs to be extensible, backed by community. So everything that Prometheus is, yes? So they were amazed about Prometheus and decided to install Prometheus on their Kubernetes clusters using Prometheus stack. But here's the drama, because they went ahead with a YOLO approach. Not thinking much about limits, not think about like how many samples they could ingest or anything else. And in the beginning, everything seems pretty fine because it just works. It's super amazing. You have like with a simple Helm install, you have Alert Manager, Prometheus, and many other tools, right? But okay, they are fine, but they start facing some challenge. And now probably you might asking who this guy that's talking to me. Well, my name is Nicolas Takashi. I'm observability tech lead at Coralogics. I'm maintainer of the Prometheus Operator and also contributor to other open source projects like Prometheus, OpenTelemetry, Perses, and Thanos. Actually, this is my first PromCon as a speaker and attendee as well, so a pleasure to be here. And while I wasn't part of the Unbounded Metrics, I've been working closely with different organizations facing similar challenges. So I hope today we learn something from their experience implementing limits and trying to make Prometheus more predictable and stable, at least in terms of samples ingestion, right? So before we go to the journey, a quick overview on their stack. They are just running Kubernetes, so they're using Prometheus Operator because this is the easiest way to manage Prometheus in Kubernetes. They are deploying Prometheus and Alert Manage. Like this is a pretty simple monitoring stack, okay? So they start facing the first challenge, the label crisis. So Unbounded Metrics grew their engineer teams, and they decided to gain more visibility on their insights. They added more metrics to different parts of the monitoring system, and I even remember engineers saying that the more we can measure, the better we can optimize. And with that mindset, folks, want to introduce a new metric to track a key service performance. But this metric has around 20 labels. But those labels were very low in terms of cardinality, like 2 values for each label, like pretty simple. But what they didn't think about is like a single instance could generate up to 148 million unique time series, so which is a pretty good amount of the time series for a single metric, right? Because like it's an exponential. If you have 2 values per label and you have 20 labels, it's an exponential value. So what is the impact of this? Like you have resources overloading because they were running a pretty small instance, so they start to see OM crashing, a lot of like disk filling up and so on. So they decide to start investigating and figured out the issue with a single metric containing a lot of labels. So they start to think about how they could prevent this kind of issue, not only by teaching engineers to avoid like all those labels in metrics, because the metrics became complex, it's hard to write in the expressions, maintain alerts, dashboards, and so on. And they just figured out that Prometheus have a feature named label limit. So they were excited about it, and they figured out as well how to use in the Prometheus operator. Well, after they noticed this is an option, and the Prometheus operator even provided another feature on top of the label limit, which is the definition of soft and hard limits. Because eventually you know that by default, like for example, if you're looking to the image on the right, you have a label limit, which is the default limit of 10 labels per matrix, okay? Like, it's pretty okay, but they know that eventually one team or another might need an extra amount of labels. So they decide to go and allow the teams go up to 5 extra labels. So they can use in total 15 labels per matrix, okay? Without defining the enforced label limit, only defining the label limit, it's going to be the default options on every scrape job. But for the ones that's using Prometheus Operator, you know that you can redefine this configuration on your monitor object. So if you have the service monitor, you can set on the service monitor the label limit. And if the label limit on your service monitor is greater than the limit you have on Prometheus, then you will be able to ingest the matrix with like the high label number, okay? So they decide to put the enforced label limit as well to have a hard stop. Well, with this implementation, they can now ensure that no services will introduce new cardinality issues by producing matrix with excessive number of labels, even if those labels were low in cardinality. And this helps avoid unnecessary resources usage, right? But now you might be asking, what happened when a service is approaching the limit, okay? Well, once a target, like in the job group, like approach the limit, the Prometheus is gonna fail the ingestion of samples of this specific target. It's gonna be dropped. And in Prometheus, it's producing a metric named Prometheus target scrape pool exceeded label limits total. And then you can even see logs on the Prometheus instance, or even on the scrape job, you're gonna be a clear failure over there. Seeing the number of labels you're exceeding, which is cool because you can quite create an alert on that, okay? And you can be notified if you have any service or any target getting to this limit. So they are happy. First journey is done. They don't have many things to do, and they think, okay, we are good. Let's keep forward. But you know, you keep pushing, you keep hitting limits. So the next one was the length label dilemma. So the team was really happy with the Prometheus because they have a great ecosystem, the two just works, and they are pushing alerts and dashboards. And they keep growing the company. And as they grow the company, they improve their monitoring practice, but they run into new problems with the length of the metric label names and label values, okay? So after a while, they note that their Prometheus instance come back using a lot of resources. And they start to investigating because they thought it was related to a cardinality issue, probably someone producing a metric with a lot of labels again, but they remember that added the limits. So what could be that? After a long time investigating, they find out a few services adding labels like geographical region, identification code includes subregions, climate, zone, populations. There's a lot of words, right? But you know, this is a very exaggerated example, but it's completely fair because you don't have any limits in place. And we are engineers, we are very creative people, right? So we like to give long names to be expressive. So they find, and the long name, label names and label values makes their time series size increase a lot because, you know, we are just storing label names in the TSDB, so it makes the time series size increase, you know. And after some time, they found the issue, and they look into the Prometheus documentation, and they are pretty lucky because Prometheus has also a limit configuration for that. So, you know, Prometheus maintainers also thinks about everything. So they discover the limits and then go again, like, let's configure some limits. But this time, they decide to not use any kind of soft or hard limit. They would like to have more predictability on the time series size. So they decide to use a label name length of 50 bytes and the value length of 100 bytes. But one thing to be aware is when you are setting the value length limit of the label, you need to understand that you need to remember that the label, the metric name, is stored as a label, as any other label in the Prometheus time series in a reserved label named underscore name, right? So if you define a very low value for the label value length, you might face issues with your metric name as well. So again, what happened when this kind of limit is approached? Well, same behavior. Prometheus is going to drop all the samples from this target, and then this time you don't have any metric telling you that this behavior is happening, but you have a clear log message. If you have any other log system, you can maybe create an alert to that, or maybe raise a PR on Prometheus and check if we can add in this metric as well. Cool. They are happy again. They contain the size of their time series. They have a strict limit on the amount of labels the engineer teams can use on their metrics. And they think that, OK, everything is good again. Keep going. But, you know, another one, the sample limit challenge. After solving the issues with the long label names and values, they feeling pretty confident. They had label limits in place. The Prometheus setup was running smoothly, and one of the engineers even joked about saying about that we have beaten the cardinality monster. There's no problem anymore. But then, as the company grew, some teams started to adding metrics with labels and had a lot of different values for this single label. This label includes things like tenant ID, user ID, stream ID, you know? So and some of the engineers also love to use the combination of these high cardinality labels with the histograms, because we want to measure latency for all our customers, right? Like, this is the better thing that we can do with Prometheus. So after they noticed the problems, they saw the number of unique time series getting bigger and bigger, leading to high memory usage, a lot of crash loop, OM queues, a lot of pressure on nodes, and so on. They start to investigating and discover that they are now facing another high cardinality issue, but they were surprised because they set the limits on the number of labels, but they didn't realize that they didn't consider actually what happens when one single label has thousands of different values, okay? They had some combinations, as I said, from tenant ID and histograms. So unbounded metrics, they are very lucky. Prometheus has another sample limit. This is a very old one. Probably most of you already faced this limit, blog posts and people talking about that. And this time, they went again for a soft and hard limit because they decided to, OK, by default, every system in our company is only exposing 250 samples. It's a pretty reasonable amount of sample for a single application. But eventually, you need to expose a little bit more because you have like a high cardinality metric with a little bit more cardinality. You need more details and so on. And they allow their teams going up to 500 samples per scrape. OK, so before they add any limits in place, they always approach the team, causing the issue. Teach the team, because it's important to teach your engineers why you're doing that, why this is problematic for your system. Because, again, we are engineers, we are curious, we want to know why we can't do such a thing. And when any engineer, any service is facing this issue again, the same behavior, the target is going to be dropped. And then we have, by default, this metric that's going to be incremented. And again, you can create an alert on that. OK, yeah. So they are glad to have fixed the main issues with cardinality, series size, making their platform mostly stable. But they are running Kubernetes, so you have outscaling. They are always running 2 Prometheus instances, like replicas, scraping the same targets, which means that those Prometheus instances are responsible to scraping all the pods on the cluster, on the node. When you have outscaling events, this might be problematic because you might go from, 100 targets to 200 targets. You can just double it. So they would like to know, and trying to figure it out, if they can manage resources better, because to handle this kind of load increase on their Prometheus instance, they are always over-provisioning the Prometheus in terms of CPU usage and memory usage, because it's nice to remember that when you're running Prometheus, it's not only about adding new replicas, because adding new replicas, you're not going to share the load of targets by default, like if you didn't use sharding. So they cannot leverage HPA by default, So they know that they have a max of 15 labels. Each label has a max of 50 bytes per label name and 100 bytes by label value. And they know in the worst case, they are going to have 500 samples per target. So they were wondering if they could have some math to predict the amount of memory required to ingest the series with this size and the amount of the samples they are going to ingest, okay? And they just come up with a roughly estimation about 37, 38 megabytes to ingest series like this, okay, with this shape. So they thought about, okay, if I know that I have 37, 38 megabytes per target, okay, and they decide to have a system target size, so which means they want to have a Prometheus instance not bigger than 24 gigabytes of RAM. They was wondering if they could like maybe enforce the amount of targets a Prometheus instance could scrape and ensure that with this data shape and this amount of targets, the Prometheus instance is keeping below or close to the limit, you know? Well, they are very fortunate. Like Prometheus do have a target limit where you can configure, and then for a target group or for a job group, when you have more than the allowed number of targets, it's going to be dropped, right? So what they did is like they just configured the enforced target limit. And when they reach this kind of limits, the Prometheus starts failing scraping Dart, starts failing ingesting sampling from this target group. And this means they are going to have this metric incremented, and they can also see the clear error on their log message and also on the scrape page. Cool. OK, just figured out that we have out of order slide. This is related to the samples limit. You can also have these extra features to get extra metrics, okay? Just get it back a little bit. So limits in place, but they now have Prometheus stability almost, right? Because they know the amount of samples, they know this average series size, you know, the Hoffman estimation. They know how many targets a single Prometheus server would scrape, you know, because they are enforced at it. So they have more or less predictability on the required amount of memory and also disk usage they need for a single Prometheus instance, okay? So they could later decide what they're going to do, how to automate the process when you have a Prometheus server reaching the target limits, you know. And then if you're using the operator, for example, you can just scale the number of shards looking for the target limit metrics, and you can like spin up new Prometheus shards and loading the target, the number of targets you have across different Prometheus instances, okay? So how to make Prometheus unbreakable? Let's recap. We have, in the early beginning, they don't have any limits, free for all. Everybody can produce any kind of metric, any shape, just go ahead. They first set the label limit just to know how many labels a single metric could have. Then this helped them solve the label overload. And the second level was to try to have more predictability on their series size by setting label name, length, and value limits. The second one, hope then solves the length labels dilemma. And then they move to the sample limit, where they can solve the issue with the high cardinality metrics, right? And the last one is the target limit, where they tie up everything together to ensure that if I have a metrics shaping like that, with this amount of targets, I can ensure that I will not use more than 24 gigabytes, okay? Bear in mind, this is a Hoffman estimation. A lot of things are gonna depending on also on the amount of unique time series as well. You might also consider if you have recording rules, because recording rules is generating new time series, okay? So all those numbers is just to provide Hoffman estimation to ingest data, okay? And I think that's it for me.
Okay, who has some questions? Amazing.
Hello, thanks for the talk. So all these limits were related to ingestion path. Can I break Prometheus with a read path by sending a query?
Yeah, definitely. Like, there's a good point. Everything that I cover here is about ingestion path. Like, in terms of querying path, we also have some limits in Prometheus. Like, for example, you have the max samples per query, if I remember correctly. Like, this is the flag. And by default, Prometheus allows you query up to 5 million samples in a single query, which means like a single query can load up to 700 megabytes in memory. And you can also have up to 20 concurrent queries happening at the same time, which means that worst case scenario, if you think about the average sample size is 2 bytes, more or less, you might need 2 gigabytes only for querying, okay, using the default behaviors, okay? This is another way that you can break Prometheus reading data.
Thanks.
Any other? Okay.
I wondered, your fictional company, when they calculated the amount of space they would need for that shape of data, did they use envelope math, or were they like measuring a running instance or something else? Yeah, like in this example was just like, how can I say that? Like just some random maps, you know, calculating the number of potential series space scrape, okay? They are like, as I said, this is a half estimation. They are not even considering the height of the time, the churn height of the time series, you know, because if you have a high churn height, this will impact on the memory usage as well, because Prometheus keeping the active time series for at least 2 or 3 hours, something like that, you know. So this half estimation is just to ingestion data. So if the ingestion has a lot of churn, this will impacting. So this is a very, very half estimation just to give an idea and understand how important is think about limits, you know, because the jokes about like very long label name, like 2 million unique time series and so on, it's real. Like probably most of you already saw that in production. When you don't have any limits, your engineers can play whatever they want, you know.
Any other questions? Yes, we have someone.
Do you have any advice on how to trade off sort of these limits and the lack of visibility if those limits hit?
That's a really good question. I mean, I think it's more how much you're willing to pay by computing resources and operational burden, because if you have a bigger Prometheus consuming a lot of resources, this will demand more operational, you know, because when you're restarting, you like replay always taking longer. Like you need probably, as you're getting bigger, you might having troubles to find bigger nodes to host a single Prometheus server. It's start to becoming a single point of failure in some scenarios. I mean, like, so I think it's balance between. You don't need to cut visibility because you can scaling Prometheus horizontally. So you can, for example, even keeping having a large number of series, but spread these across all different Prometheus instances. But like in terms of only one Prometheus instance getting all the things, I think is how much you're willing to pay this resources usage, you know. Because I think in the end, it's everything about computing costs, you know, like you want to reduce this somehow.
Thank you.
No more. I guess. Thank you, Nicolas.
You're welcome.
Thank you so much.
Thank you.